Just go to handin.cs.clemson.edu, and I put that link in the project description right at the bottom. And then choose your course, 870 for example. And when you go in there, there should be some buckets. I think it's pretty self-explanatory. You can do this from anywhere. You don't have to be on campus or within the firewall. You can do it from your home or your bathroom or whatever, as long as you have an internet connection and a browser. So that's all you need. Okay? So, zip up your directory. Put it in a directory, and then either use zip or tar and compress it so that I get all the media and the XML files so that I get everything. So compress the directory and stick it in there. Excuse me. And you can submit it as many times as you want. And preferably, if you use the same name, I'll know which one it is. If you use different names, then there'll be a bunch of them. And I don't know what I'll do. I guess I'll probably take the most recent one. But it'd be best if you could just make sure that the tarball or zip file has the same name every time if you resubmit. Okay, any questions about that? Yeah, Pat.
Do you want us to clean our build before we send it?
Yeah, I wish you would clean, definitely. Because I have a Python, it almost doesn't matter except it takes more space. I have a Python script that I'll run through there, and it'll go through and it starts by doing a make clean and then a make. So yeah, if you'd make clean, and also if you remove the SVN stuff, it might help too, because there's some directories just to make the tarball smaller. As we progress through the semester, your project will get larger and you'll have more media files. Good question. Any others? Yeah.
I noticed there was a checkbox for hand-in to extract the zip for us. Do you want us to actually leave it as a zip?
Just leave it as a zip, or yeah, I can unzip it, and that way it'll be compact. And then I'll use Mercurial to get them, and then I'll just have a Python program that runs through it, and I'll unzip them for me. It checks the suffix, and if it sees, excuse me, either GZ or zip, it'll take care of it. If it sees RAR, it explodes.
Do you mind I change the background?
What?
Do you mind I change the background and the image?
What's that again?
I want to change the image to another one to make some font.
You want to make the font?
Yeah.
Make a font?
Yeah.
Yeah, change anything you want.
Okay.
Excuse me, I'm having trouble. The framework that you start with, you can change that, whatever you like. And in fact, what I've said is that to get 90%, you have to do the specs, and then to get an extra 10, you have to do something extra. And if we go to the directory, to the projects directory, I didn't update, I guess. Let me update. And just to give you an idea of what the future projects will be like, these are going to be the things we'll be doing in the future. So the next project will put a viewport that will track a sprite. I'll introduce multi-frame sprites. We'll use the factory pattern and the flyweight pattern, those two. So when you do your extra stuff, I prefer that you don't do stuff we're going to be doing anyway. So for example, one of the things you can do for this first one, I think it would be a good idea, would be to find the average frame rate. I have and I'll show you that. We'll look at that, I hope. Let's add that to the agenda as if we need one more thing. But let's talk about, this is the I/O manager that I wrote. And in there, it does some stuff. And one of the things it'll do is it'll write text to the screen for you. We can take a look at that right now. It won't hurt to take these things out of order. Let's actually go there just for a moment and take a look. So if we go to the framework, and I want to come back to it, of course, but there's an I/O manager. And it has some things that we're currently not using. I use load and set probably to load the sprite. That's how I load sprites, and I think I use that in the manager. But this will print a message. Let's use that in a moment here. And it's a singleton. And unfortunately, I use the new kind of singleton here, so I'd like to try to talk about that, but I'm afraid I won't be able to fit it in this class, but we'll definitely be able to fit it in next class. But I can show you how to use it. And so we'll use print message at, and there's an FPS.
It's on the clock.
Oh, it's in the clock class. Yeah, one of the things I'd like you to do is get used to understand these classes. Let me grab this and let's stick it in. I'll show you how to write text. So if we compile this and run it, this is what we get. But what I could do is I could go into here and come down here, and excuse me, in the event loop, right before I do the flip, I'll go to the draw, I guess. So here's my draw function. So there's draw. And what we do is first we draw the background, then we draw this single orb. You'll be drawing a bunch of orbs, and then I do a flip. If I don't do the flip, I don't see anything, right? We know that. So we have to do the flip. That flips the buffer. But one of the things I can do is print a message. So all I need is to use the this, and so I can print a message. Something like that, and then uint32 I think is just an unsigned integer. So we'll put this at, this is the x coordinate. Let's put it at, say, let's put it at x equals 200, y equals, say, 30, and then there are other ones you could use, of course, and then if we make this and run it, we don't get anything. Why is that?
Errors.
It has errors?
Yeah.
I hate that. On line 39. What do I need? What's const? Huh? Oh, yeah, we don't want that. Yeah, I didn't see that. See that every time I cut and paste, if you notice, yet I still do it.
And I think that.
Did I do another one?
Yeah, you went 32.
Oh yeah, we don't need to tell it that. Thank you. Anything else, Patrick? Or whoever was talking. All right. Maybe it'll compile. Yes. Okay, so there it is. Now you can go into the XML and change the font size, change the color, even change the font if you like. So it's easy to print stuff to the screen, print text to the screen, and then there are other ones in the. I think it's print message value at. Let's change it to print message value at, and then I think we can put number of orbs, and then I think it takes. Oh, we don't have an orbs dot size. I'll just put one, I guess. But you can put an orbs dot size there, and it would tell you how many orbs that are in your. Let's see if that compiles. Amazing. Okay, so you have your vector. You can, it's whatever you're storing whatever the name of your vector is, you can put vec dot size there or whatever. And okay. Okay, great. So that's putting text to the screen. And then if you look in the clock, I really should talk about the clock. I'm kind of taking things out of order here. I hope it's not going to be too confusing. We talked about the game clock last time and the CPU clock. And we want our animation to run by wall clock time. So this is how I do it. And what you'll notice is almost everything is in private except get ticks. But what I want to do is get the number of ticks that have elapsed since the last frame. And this class will automatically do that. I really should talk about it. Let me come back and I'll calculate the FPS. I won't come back, I'll do it now. So this get FPS. Let's just see if we can use it right now. We can even use that text thing, and it's just get FPS. And I think you'll see I'll make a mistake, which you'll enjoy. So let me come down here to the draw, and let me actually, I don't know why I have an extra line there, but let's print, I'll stop. Okay. the FPS is, and it's clock.get FPS, and all you gotta do is change that to maybe 50, and I'm thinking we're gonna get 0, and we might even get a warning, I hope. So it's good I'm doing this. We didn't get 0, it's working. Okay, now why is it working? Let's come back. It's working because, see, one of the things I have to do is I have to update the number of frames every time through the event loop. So what we have in there, in the manager, is an event loop. So let me go into the manager even as this is running. What's wrong? So Control Z, I put it in the background. I'm going to go into the manager code, which is already there, so I don't need that. Where is the manager? It's hidden. There it is. There's the clock code. Here's the manager code. So what I do in the event loop, let me show you do you know what the event loop is? The event loop is this while loop. We do our own event loop. If you're used to Glut, Glut does the event loop for you. The event loop is the thing that runs. And I can't quite fit it all in, but I can. I lied. I'm going to put all the event loop in there. For some reason it won't go. I know what I can do. It's Alt, isn't it Alt? Yeah. Aha, see? Okay. So somewhere in here I must be updating the clock, but I don't see where. Oh, it must be an update. An update, I must be updating the clock. And what the clock does is simply increments. Oh, okay. This is probably not a good use of overloaded operators, but I overloaded plus plus to increment the frames every time through the event loop. So let me try to now find in here, if you look at the code, the plus, this is overloading it both ways, so I can do clock plus plus or plus plus clock. Now if I split this, what you see there is the overloaded operator. Are you completely confused now? All it does is updates the frame. So each time through I update, it's another frame. Are you with me? So FPS is keeping track of the total ticks and the total number of frames and dividing. So frames per second is the number of frames divided by the number of seconds. So I remember the SDL clock is in milliseconds. So I divide by 1,000. So to compute FPS, did you see that go by? Yeah. To compute FPS, what do? I multiply frames by seconds, and then I have a function to get the seconds. To get seconds, just gets the ticks, which is in milliseconds, divides by 1,000 to change it to seconds, and I divide frames by seconds, and I return that. Now that's the number, that's the frames per second since the beginning of the animation. But most video games, what you want is the average frames per second. By that, what I mean is the average frames in the last, say, 100. So what you can do is get a vector or get a deck. I think a deck might be the right thing to use, but if you want to use a vector, I don't know. Compute the frames per second in the last 100. Something a little harder would be to cap the frame rate. How many of you play video games? Raise your hand. That's a lot of hands being raised. How many do not play video games? Come on out of the closet. I know, you might as well come out. All right, so that's okay, but if you don't play them, you might not know this, but most games cap the frame rate to keep the animation smoother. You cap the frame rate. And of course, then you can get things to circumvent that. And so if you own a type, graphics and video graphics card, how many have a type? That's good to see because they cost them. How much do they cost? They're down to $9.99. That's for the graphics card. So you buy a workstation for $550 and you get a Titan for $1,000. Anyway, so you can up the frame rate. So that's one of the things you can do. Some of you are doing multi-frame sprites. I don't mind that because the reason I don't mind it is because, well, we'll come back to it. We're going to come back to our frame. So I've done this one. This one's done. Okay? all the women know that I've done this. The men can't see red. They don't even know I crossed it out. And I've done this. So let's do vectors, then we'll go to the frame, and then I want to talk about valve grind and finding leaks in your code. You don't have to worry. SDL has a boatload of leaks. I don't care. In fact, some of you may be able to figure out how we could turn off those leaks in the valve grind. If you figure that out, let me know. Let's come back to that. So let's just talk about vectors. So why do I want to talk about vectors? I want to talk about vectors so that you understand what happens under the covers. We're all trying to get under the covers, aren't we? Oh, this is being recorded. Can we erase? Oh, no, leave it in. Who cares? So we're trying to get under the covers here. So that's what I want to try to expose to you today. Because when you use vectors, if you don't use them, if you don't know what's happening, you can really be inefficient. So let me just start off. Vectors are easy to use, and you may never have seen them before. I don't like to bring everything in from the standard library. I'd rather put the STD typically. There are plenty of ways to bring the library, the standard library into scope. When I do it this way, I know where that came from. It's not as crucial as something like Python, but still it helps. So I'm going to have a vector of ints. Let me just write a function to initialize the vector, then I'll write a function to print it, and then I want to show you what's happening, how it's doing it. So let's write a function to initialize it. So I'm going to say void init, and then I'm going to do something you should never do, and I get screwed every time I do it. So we're going to pass it by reference, okay. And now I'm just going to, let's have a number. We'll have a const int max equals 10. What did I do wrong?
Line 12.
Oh, okay. I think one's enough. Thanks. Okay, so now let's just go ahead and for unsigned int I equals 0, I less than max plus plus I. Now there's lots of questions here that you'd like to ask, but you're afraid. Okay, because you're a wuss, you're scared. Like what? Why is it an unsigned? Why is he doing plus plus I instead of I plus plus? Is he just like weird? Well, we know he's weird, but is there another reason, right? Is there, Paul? Why would we use plus plus I instead of I plus plus? It can be more efficient, yes. It can be more efficient, okay? Plus plus I actually can be more efficient than I plus plus. Joey, your pen is up.
I was going to say, I think the plus plus is evaluated immediately. It's performed immediately, right?
And so you don't need a register to save the value. So you may save a register allocation.
And you have that value through the loop as well.
That's right. So when you do plus plus, when you do I plus plus, that isn't evaluated till it reaches the end of the statement. So therefore, it may have to save that value in a register, and you waste a register. So yes, you are absolutely, you knew that. So we want to push back, rand mod 100. Does that look right? Yeah, that looks good. So now 1, 2, 3, 4, 5, 6, 6YYP, and I'll print it. Now I'm going to do it differently. Now it's a const. And what I do wrong here? Yeah, we don't want max here, do we? Size. So nausea, we just want size there? Was it units? Who said it? Who said just size? Just, what's that? Oh, vector size, okay. Okay, let's see if this compiles and don't want it moved. Okay, I don't care. I'll move it. Wait a minute. Oh, in the wrong place? How the heck? Where'd this come from?
It's a different window.
Is that a different window?
Like a different desktop.
It's a different, yeah, desktop. I don't know how that happened. Okay, let's see if it compiles. How many say it'll compile? Oh, about 4 of you have faith in me. How many think there's no way in hell this is going to come? Heck, this is going to compile. Okay, there's no way it's going to say no. Okay, we'll compile it. It does compile, and we don't get any output because we didn't call the function. All right, so let's actually call the functions this time. We want to say init vec print it. Now we'll actually, now will it compile? It does. Okay, so what's happening? What's happening under the covers? Let's crawl under the covers. What's happening under the covers? That's what I want to know. It's really important. Like, how big is that thing? How big is that vector?
It's dynamic.
It's dynamically allocated. It's stored on the heap. So it's dynamically allocated. How big is it?
Max.
What?
Max.
Max? Yeah, it's max. It is. This is the thing. That's what we want to know. And really, what I'm going to do is move that up. So what's happening? Let me just do it.
Yeah.
What did I do wrong? You know, you think the compiler nowadays would see that and just fix it for me. It's getting worse. Okay, you know what I'm going to do? Some of you know what's happening. Do you not? All right, I'm going to print size, and then I'm going to print capacity. And I'll even print a message. Do you want to see what's happening, or do you already know? Does anybody know? What?
I know if it reaches its capacity, it will double.
It will double, that's right. So it starts off like this. Make sense? Then we push back. We do a push back. Right? Then we do another push back. Then we do another push back. Then we do another one. What's the next two numbers? 5, 8, you got it. 6, 8. Nine what? You see? Worse than that. It's worse than that. Watch, I'm going to... It's like we said, but it's worse than that. Okay? Because what's happening? I'm going to show you. I'm going to pretend I'm the runtime system. Okay? I'm on the heap. I make room for one. Then what do? So I allocate 4 bytes. Then what do? I deallocate 4 bytes, and how much? Okay? Then what do? Deallocate those bytes and allocate that. Then I'm okay. Then what do? Deallocate that and allocate some more. Now you see why Dr. House won't use them? Okay? It's worse than this even, but that's what's happening. Yes.
So why vectors over like a dynamically allocated array?
What?
Why vectors over a dynamic allocated array?
Oh, because they're so much better, Jonathan. It's pitiful to use a dynamic array. What can I do to fix this?
So capacity.
Yes, set the capacity. That's right. And you said that, and I forgot how to do it now. I knew I do know how. So all I want to do here is right here. Jonathan, you watching? So look at that. Now watch. Now I'm going to run it. You see what's happening now? Now I allocate 10, I fill up 10. Now this will be on the test. We'll have a test in about 10 days maybe. Don't worry. Suppose I add one more, number 11. I added 11. Jonathan, what size and capacity if I add one more item? 11 and what? No, no, no. Double. I want you to double when you reproduce. Be like a rabbit. Okay? Be like a rabbit. So if it's 10, 10, size capacity, and I have one more, what is it?
16.
11 is the size, 20 is the capacity. 11 will be the size, 20 will be the capacity. Okay? What happens if I push to the front? What happens if I do a push front? If I've got 10 things in there and I do a push front, here's what it does. Deallocates, puts it here and moves everything down. So as a result, the standard template library won't let you do a push front. You have to change to a list then. If I try to do a push front, I'm hoping, I'm going to do a vec dot push front 77, and that should not work. See, look, you see what it says? No member name push front. If it's a list, I can push front. If it's a map, I can do it. But the standard template library says if you're trying to push front, you're an idiot. You should be using a dynamically dimensioned array because you're pathetic. Okay, is it possible to push onto the front of a vector? Well, of course it is. Of course. C++ will let you do anything. Okay, you just push. Is it insert? Is that it? Paul, you ought to know this. Is that right, Paul? Huh? Maybe. I'll say. Of course that's right. You see, and I did it. Don't do this. Don't do this. What will you do in that case, Jonathan? Not a dynamically dimensioned array, you will. No, use a 4-letter word. What is it? Maybe I better tell you this. List. Okay, list. You'll switch to a list.
What's the capacity now?
The capacity now? You know that. Why are you asking me that?
20?
20? Did you say 20? Good man. You want me to prove it?
Yeah.
I knew it. See, that's good. He doesn't trust me. You're smart. He's smart. What's the size? What's the size, Jonathan?
11.
11.
Oh, cool.
Yes.
Instead of
Identify yourself.
yuan,
What?
yuan.
Never mind. Go ahead. What is it?
Dot reserve. What if I use set resize?
What? Don't use resize.
Never use resize.
Nah, I don't use that. That's not good. Did Myers tell you to use that?
No.
Who told you that? Did Dr. Levine? Don't listen to him. Don't listen.
I'm curious, but because you use a reserve and it will change the capacity.
I don't know. I don't know how to resize works. Yeah, I'm using the Dr. Hallstrom approach. You know, what do you think of model view control? Oh, that's a good pattern, Brian. How does it work? Don't use that pattern, Brian. I don't know how resize works. I never use it. Okay, it's worse than this. It's worse than this. Let me just, I'll ask questions now. Oh, you want to erase something?
Yes.
Oh, okay. What do you want to erase?
Everything.
Everything. Who said that? Oh, Casey, you're terrible. All right, I'll tell you what, I'll erase one and I'll let you figure out how to erase them all. So let's write a function, delete 77. I'll try to do it fast. The repeat. Oh, that's even better. We'll delete repeat. Oh, I don't know how to do that. I do know how to do it. That's n squared. Should we do it? I will do it. Delete repeat. Oh. Why did you do that? Oh, that's so hard. Let me just delete 77 for now. And then we'll do that. Okay, so what do I want to do? Okay, yeah, hold on to your seat. Are you ready? What am I doing? Paul, are you ready to come up and do this? Whenever I get stuck and can't do something, I'm calling Paul. He can do everything. Then we got to do while. Ah. Oh, I'm doing it wrong. Okay, so what am I doing? So I'm going to delete 77. So I need an iterator. Because to delete something from a vector, I need to use the function erase, which is a function in the vector class. So what I need to do is use an iterator. I'll actually use this to, I can do this to print too. And I believe it's faster, isn't it? Is it a little faster to use iterators than your hand is up? No. You're just grabbing the air? What do you, that's a scary image, probably. All right, so anyway, I'm using an iterator. An iterator is a pointer. It's a pointer to one of the nodes in the vector, an entry into the vector. So it's a pointer. You don't see the asterisk anywhere, but it is a class, really, that maintains the pointer. And vec.begin is a pointer to the beginning of the vector. And vec.enda is a pointer one beyond the vector, one past the enda. So it's a lot. So vec.enda points one past the enda of the vector of. If I say vec.end, everybody says end. Where's end? I don't see an end. So I say enda. All right, then we ask. I don't want to say if the pointer is 77 because the pointer is an address. If what the pointer points to is 77, then I want to erase it. I erased it, it's gone. So what's the pointer now pointing to? I don't know. But erase returns an iterator, a pointer iterator, to the next item in the vector. So I set pointer to this net, whatever this returned, which is the next item in the vector. Otherwise, I want to avoid the infinite loop I've been in all of my life. Okay? You think it'll work? Why not?
You got an extra colon on your iterator there.
Where at?
17.
17. After your iterator colon. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17. 17
Yeah, that's just in case. In case you're not paying attention, Paul. My online debugger. Anything else? I guess we better call it. Oh, I did call it. $77's gone. You see that? It's gone. It was there. It's there twice. It's gone. As an exercise, I could do it now, but as an exercise, I invite you to delete all the repeats. Yes?
So does the capacity stay the same, or does that also?
Oh no, the capacity changed. No, the capacity, oh wait, no, the capacity always stays the same if you delete. The capacity's, I'm sorry, the size changed. But the capacity is still the same. Here, we'll fix it. You see how nerdy I am? What?
Random numbers, right?
What?
Random numbers, right?
Yeah, but he's talking about the capacity, not what's in it.
Why did you choose the same?
Well, it's a pseudo-random number, generally. You know, it doesn't say, oh, I already did that one. See, capacity, see, Casey, that was a good question. Capacity stays, it doesn't change the capacity when you delete, but the size changes. Wait, it went from 11 to 9?
Yeah,
Got rid of all of them. Okay? See why computers are better than humans? Is your pen up?
Yeah, why do you use unsigned in?
The question is, why do we use unsigned in? And the answer is because size is an unsigned in. So if I had used an int here, that one will be okay. Oh, it's gone. Where's print? If I had used an int here and compared it to, so this is an unsigned int. What's your name?
Praveen.
What?
Praveen.
Praveen. Praveen. If this is an unsigned int and this is an int. Did I make that an int or I made that an int? Oh, and this is an int. If this is an int and that's an unsigned int, I'll get an awful thing happening. Okay, an awful thing will happen. Oh, heck. Paul, did I save it?
Why don't we just read it as retreat the sign bit as a number, and it'll just be a really large number.
Oh, shut up. What?
Let's just read this int as a.
I should get a warning. Because I'm comparing an int to an unsigned. Ah, I'll bet I don't have the flags on. Maybe. I don't know why I didn't get. There's. What warnings do I need? What's another one, Paul? What is it? Yeah, but I don't think Myers checks for that. What's the one for pedantic? You're cruel, you know.
You can put flags on your pile.
Oh, is that the problem? Oh, no wonder. How do I do it, Joey?
I would think before object. That,
Huh?
that'll do it. I don't know if it matters if you put it before objects or after.
I should put it before. That's why I didn't get a warning. Now I'll get probably about 5 of them. Or I'll get them with the makefile error. There we go. What? G++ minus W all main.cpp. Thank you. Thank you, Jesus. Look, warning, comparison between signed and unsigned. Praveen, you don't want warnings, do you? Do you? You shook your head yes and you said no. What? What is happening to me? Okay. Okay, so let's.
Is that one dash GDB supposed to be that way?
What's that?
Dash GDB.
Are you asking me about a makefile?
Well, line 4, the flag says dash GDB.
No, shouldn't that be GDP?
Dash G.
Dash G, is that all?
I think so.
Thanks, Casey. Let's see if it'll work now. There's something wrong with it. I don't know what's wrong. There's something wrong with it, Casey. I'll try to fix it offline. Okay, let me just show you one more thing because, and then we gotta move on. So, here's the deal. You're gonna be pushing sprites into your vector, okay? Now, when we move to the second project, we'll be pushing sprite star. And some of you guys are actually, I don't know what you're doing for these multi-frame sprites. How's that working out for you?
I just made other frame.
Ooh, you're hacking. That's called hacking. Yeah, when we use polymorphism, we need a vector of sprite star. But for this one, we'll have a vector of sprite. And what I want to show you is the well-known fact that what you put into the vector isn't what's in the vector. And what you take out of the vector isn't what was in the vector. That's the way Myers says it, and he gets away with it in his book. So, what do I mean by that? Do you know what I mean by that? What you put into the vector isn't what goes in the vector. Are you throwing up? What do I mean by that? What you put in the vector isn't what goes into the vector.
This is the copy constructor.
Oh, somebody said, who said that? Patrick. Man, he said it uses the copy constructor. This is significant. Every time you put something in the, now you know why Dr. House won't use them. Every time you put something into the vector, the copy constructor for that item gets called. Okay? So does that mean we probably want to use pointers? No, don't jump to that conclusion. Especially you macho types. Oh, I want to use pointers. I'm so tough. You know? Pointers have their own problems. You have to allocate, you have to deallocate. Don't just jump to the conclusion, oh, I should make everything a pointer, because that's ridiculous. Okay? The truth lies in between. But I want to show you that, in fact, the copy constructor gets called. So what I've done here, it won't move. So what I've done here is I've created a class, and all I'm doing is telling you what's being called. And then down here, I'm going to push back 1, 1, 1. Why am I doing 1? How about 1, 2, 3? I don't know. Why is that a 1? How about 10? 21? Oh, 2. Now, this is sneaky. This is so sneaky. Watch. You see? Why? What is going on? Do you know what's going on here? We're slipping under the covers, aren't we? Yeah.
When it resizes, it calls the copy constructor each time.
Yeah, that's one of the things it does. Yeah. When it resizes, it has to call the copy constructor. How about when it puts in? It calls the conversion constructor. Why? Because I'm pushing in a 10, but this is a vector of number. And it wants to put a number in there. It says, that's not an NUMBER, it's a 10. But I can convert it to an NUMBER by calling the conversion constructor. So it calls the conversion constructor not once, not twice, but thrice. Okay, it calls it thrice time. Count them. 1, 2, 3. Look at all those copies. As someone said, as Will said, when it resizes, it not only has to reallocate space, but it has to call the copy constructor. So that's an argument for one thing, really, using reserve. And I would like you to try to use reserve on your first project if you know how many you're going to put it in there. Now the amortized running time for insertion into a vector is order log n, I believe. Now, if you take Ryan Dean's class, he'll probably prove that 5 different ways. Or maybe 7, I don't know. But that's the amortized running time. Yeah.
Can you
Or
control?
is it order n? Or is it constant? Maybe the amortized running time is constant. Does anybody know?
Look at the circuit's constant.
For insert, it's constant, even with the amortized running time. I think you're right, Pat. Yeah, Joe.
I'm just saying, can you control how much you allocate when you have to add a new node? So instead of, let's say you reserve 10, can you set the increment to half instead of doubling? So you may, from a memory size standpoint, you may not.
Yeah, yeah, there are all kinds of things you can do. Check the functions available in the vector library. And I think there are things you can do.
That's a pretty bad penalty if you only need one more.
That's right, that's right. Yeah, I think there are things you can do. There are functions. I don't use them, but, you know, I've already told you, you know, here's C++, here's me, and some of you, or some of you are here. Here's Paul. Okay, so that's enough about vectors. Are any questions? Yeah.
What does that look like if it's number star for the vector?
Okay, if it's number star, it's not going to call any copy constructor. It'll still resize. It'll still resize, so that's where the reserve comes in. Okay, so, and in fact, if I made it a vector star, it wouldn't even call the conversion, and that won't work. So I'd have to do a new number, left paren 10, right paren. Okay, that's a good question.
So for our program, our project 1, we wanted to do it.
I'd like you for the first project to use a vector of just sprite, just to see you use that. You know, and use vector of sprite and reserve. And then when we go to the second project, we'll go to a vector of drawable star. Because in the second project, you're going to have multi-frame sprites. Okay? Okay, let's go to the Y frame and then we'll go to Valgrind. So Y the frame. And for this part, I want to go to the framework, which, where'd it go? There it is. Let's go to the framework here, and in fact, let's go to the docs. Can you see it? Okay, so these are the classes that we have. And I'd like you to drag them, I'd like to drag you through some of them. So there's a lot of classes. What are they for? Well, you know what the manager class kind of does. Right now it's kind of a God class, lower G, in the sense that it choreographs all the activities that occur in the animation. It does too much. And as we move on in the semester, we'll start using design patterns to help us allocate responsibility to other classes in the system. So, and what it right now has, the framework right now has one org, so it has, which is a sprite, okay? And that sprite has a single frame. Now, the biggest thing in this whole system right now is going to be the frame, because the frame has a surface, and surfaces are large, okay? Are you with me now? So they're large. Suppose I want a vector of 100 sprites. What that means is I don't mind having 100 of these because there's not much to this. It's got an X and a Y and a pointer to frame. It's got an XY location and a pointer to frame. It's maybe, you know, 12, 16 bytes. This baby's going to be bigger because it's got the sprite. So if I have 100 sprites, I don't mind having 100 of these, but how many of these do I want? Just one. Exactly one. Then you can have 1,000 sprites. That's why, remember, I crowded the thing with sprites. It kept running. And the reason it kept running is there was only one frame, but 1,000 of these. So it's much more efficient. So a lot of people might think, oh, I'll just move this in here. Don't do that. Okay, for two reasons. Number one, you're going to want a lot of objects of the same type. So what you do, you don't have a lot of surfaces, a lot of frames. You only have this one for all those objects, and you draw them at different places. So it's in here that I keep track of the XY, and I didn't put that in there, the XY, but that's, oh, the XY's up here, okay? Everything that derives from drawable, this is drawable, let me show you. Oh, sorry. So everything that derives from drawable has an x and a y. This is get x, get y. We might want to look at that sometime. A get position, get velocity. So it has position, which is a vector, a velocity, a max velocity, and it has a name. The name is useful for when we read it from the XML file. Okay, we just tell the sprite, go load yourself up because you're an orb, you're a green orb. And then it knows how to go to XML and get all that information. And so it gets. Now, one of the things it uses is extract frame. So the question right now is, if I'm going to make up 100 sprites, where am I going to store the frame? Well, for now, I've got to store it in. It's in the manager, and I don't have it here, do I? Manager has a frame. So manager stores a frame. So I should have a pointer from here to here, or an arrow from here to here. Because this guy has a pointer to it, but this guy gets it from here. So this guy actually reads the frame. Let me just show you that right in the code so that you can see that. So if I go to your project and go to projects, 1, and then framework, let me just show you what the manager has. So look, the manager keeps the frame. And when it makes a sprite, if it makes 100 of them, all 100 sprites are going to get this passed in. So I want to use the constructor that takes this frame. And I want to reuse that frame. Now next project, project 2, we'll make a flyweight and we'll make a factory. We'll tell the factory to go make it and it'll store the frame. Because this is stuff that the manager shouldn't be worrying about that. So we'll allocate this resource management to a factory class. Okay? And the factory class will check. We'll say to the factory class, give me a frame for green ore. It'll look up the name. If it doesn't have that anywhere, it'll go build one. If it already has it, it'll give me the pointer, and I'll just have it be a pointer, and I'll reuse it. You with me here? Okay, good. Good. All right, so I only want one frame, but I may have a vector of sprites. In fact, I already did this for you, and I think I still have it, and I can show you that that is, in fact, the case. I think I can if I go to my place. Remember I started this? If you look at my manager, you'll see that what I have is, I have a vector of sprite, and I have the frame. And when I make that vector of sprites, watch what I do. So I make the orb frame. One time. Only one time, I hope. And then I make the orb. See, here's a function called make orb. Take a look at orbs. Because I want you to do this right and not lose a bunch of points. In make orbs, I'm reusing that orb frame. That frame's being used for all n of them. Okay? I reuse the orb frame, but I instantiate a new sprite. So I may have 100 sprites, but only one frame, and it's this frame that's big. If you have questions, now's the time. Paul, you have a question? So, and I shouldn't have any leaks. We should come back and look at this. So that's Y frame. Now there are other classes I'm using. I want to give you your quizzes back too. But there are other classes here. So what's game data? Game data is a singleton that contains all the data about the game. The size of the viewport, the size of the world, the number of frames. It'll have all that in here. So I put functions there to get an int, to get a floater, to get a string. And I think there's a get boolean there that I didn't add. Okay, to get a boolean. And then I get a copy of the data. I actually store the data in this map because I use a copy constructor to store it. So this is where the game data will be stored. Now, I only have one. This is a singleton because all the constants pertaining to the game or the animation will be in here. So the parse.xml is not a singleton. Parse.xml is not a singleton because I may want to use it for other things like save games or whatever. So it's not a singleton. So game data calls parse XML to get all this stuff. Parse XML loads all the game data into this map, which I haven't even talked about, so don't worry about it because you don't need it to know it. Just call the functions. But I'll talk about maps soon. But then I get that map, and the map is actually stored here. Now, if you want to change that and do it a different way, fine. And I could even send you a C++ parser for JSON if you want to use JSON. Send me an email, yeah.
So for this diagram, is this being generated or is this something you created?
I created it. Do you have a good tool that will make it for me? Doxygen, yeah. I'll try Doxygen. Yeah. Do you use Doxygen? You show me how to do it sometime? All right, I'll buy you a beer. I actually don't drink alcohol, but I'll have a coffee. That's why when my brother orders these bottles of wine, $2.20, I mean, like, oh. All right. So should we go to Valgrind? There's more I could say about this framework. And when we go to multi-frame sprite, it'll derive from a drawable, because this is an abstract base class. And I'll talk about inheritance and abstract base classes, but because it's abstract, every class that derives from it has to have has to instantiate the abstract ones. These are abstract. See them in italics? Draw and update. They're in italics. I use diet, and that means they're pure virtual. And then I get reuse. I reuse position and velocity because even though it's a sprite or a multi-frame sprite or an exploding sprite, it doesn't matter. I still want it to have position and I still want it to have velocity. Okay, and I want it to have a name so it can read itself from the XML. So this guarantees some uniformity across the different types of sprites that we'll have in our animation. We have a sprite, we might have a 2-way multi-frame sprite or a 4-way or an 8-way or an exploding sprite, multi-frame. I mean, all kinds of different sprites to juice up our animation. We might have an L system, and it'll be a sprite. That was close enough, I thought. Okay, you want to ask any questions about it? So this is the high-level view. Remember, some of you tend to want to learn bottom-up, some of you tend to want to learn top-down, but current research tells us that we all learn in both directions, really, and that both views help us all. So I want to try to give you both. It's like the Kinsey scale, you know. I think all straight is, is what? 0, and all K is 6, and in the middle, oh, I'll have to erase this. In the middle is a 3, and Kinsey said, well, nobody's at the either end, I don't know. So it's like that with learning. When you learn, you don't learn all top down. You don't learn all bottom up. That's what they say. And I think it's true, by the way. I think, for example, for me, I tend to be a bottom up type of person. So I like to get down into detail. But I can tell you it sure helps me to have a top-down view, an abstraction of the code. And that's why UML diagrams, I think, really can be helpful. If you want, it might be instructive sometime for me to draw you a sequence diagram for the interactions here. Do you know UML sequence diagrams? Time goes this way, and you have an object, and you do the invocations. I might try to build one for you to show you that too, because it's an abstraction where you abstract away the details. I'm sorry, someone had their hand up.
Question. Kind of goes to Valgrind.
Okay.
In the destructor of the manager,
Yeah.
you delete the frame.
Yes, I'm glad to hear that.
But I was trying to figure out why you have to delete the frame, because we're not calling mu when we make the frame.
We don't?
Shouldn't C++?
No, I do.
Okay.
I do call him. And you're right, though, Lauren. I'd like to make sure everyone heard what he said. I only delete what I knew. NEW knew. Okay, if you NEW it, then you DELETE it. All right? But if you don't NEW it, then you shouldn't be DELETE it. Okay? So that's the rule. Except when we get to the factory method. Well, no, that works there too. The factory method will new it, and the factory method will delete it. So the principle will hold, actually.
And in vectors, will C++ go through the vector and delete everything for you when the vector gets deleted?
Well, we don't delete the vector because we didn't know it.
Right, so.
So you're
vector
worried about the
deletes
heat.
content.
You're worried about the heat. So what we could do, I think I know what you're saying here. This isn't the right one. Let me go to, let me go here. That's a good question. So here's what Lauren is asking. Oh, heck. Does anybody know where that is?
This one.
There it is. So what he's saying is, I'm putting a bunch of things in here, and that memory is allocated on the heap. But I don't think it'll matter, Lauren. I think that when it falls out of scope, clear will be called. So let me just try this, and I hope I don't get any leaks. Let me run valve grind. Now we'll go to the valve grind part. Valve grind. So let's go to the valve grind part. Okay, so I got a bunch. How many do I have here? A whole bunch. Okay. And that tells me I think there's some leaks in here. What should we be getting? Okay, let's talk about what we should be getting. I'm going to go to your place, and I put a valve grind directory in there, and here's the dot leaks. Let's try to get rid of these leaks. I'm confused about why they're there. Okay, so let me run this. Okay, so that's all it does. Let me show you the main program. So this is a bare bones program that has virtually nothing in it. Okay, so we didn't NEW anything. We didn't new anything. So let me run valve grind. Did that work? What happened? Man, so that's what's, I didn't do that. That's not me, that's horrible. So this is, if you don't have any leaks, this is what you should see. If you don't have any leaks, this is what you should see. Okay, now the question is, how come I'm getting these leaks? So let's try to get rid of them. So let me try to convince you, Lauren, that if I go up into the destructor, and I do an orbs.clear, I don't think that'll help. Let me see if that's the case. That, by the way, Lauren, that'll clear that memory in the vector. Did that do it? So we still have some things that are lost here. Where is it?
You didn't delete back.
What?
Back frame.
Thanks. You know, the way to do it is to use valve grind. We'll use valve grind together. Would that be the whole thing? Was that it? Oh man, we got still reachables went low. Let's see, what else? So let's use valve grind and see if we can find what we have. Valve grind will tell us. So let's try it. So what we want to do is we want to say valve grind minus leak check equals full ./run. And then we'll look and see where the leaks are in our code and where the leaks are in valve grind. Okay, so let's go back. Okay, so nothing, we have done nothing wrong so far. Nope, see, that's all, we lost some bytes in here and in here. But that's not me, that's STL. No, that's in the NIT. Oh, something's in STL. No, see, these are all STL functions. So these are not me. Oh, I wonder if it's my IO manager. See, when you see a malloc, that's definitely not us, because we never use malloc. Don't use any C functions. Don't use printf. You can use any string C functions, though, if you need. I don't think there are any leaks in here. Let me just check. Yeah, I don't have any leaks. I don't think I have any leaks. I think this is devoid of leaks. I'm pretty sure there are no leaks in here. Does anybody see any? Paul, you see some? Anybody else? I'm sure there aren't.
Is it possible to force STL to more humanely delete instead of letting STL do it?
Third-party libraries always have leaks. You check. We're using Flex and Bison and 827. They all have, I think. Well, I shouldn't say. Maybe OpenGL does. Glut's got way more than STL. If you're using Glut, you automatically get boatloads of leaks. OpenGL might not do that, but Glut does. I know that for a fact. So I think I'm clean. I think that's what you should get. If you don't get that, then you may have some leaks. But really, I think the only thing you'll be doing are frames, so you shouldn't have to worry so much. It'll get worse. So get used to finding leaks. I don't want you to have any leaks. Okay, we did a lot. I almost never am able to cover all the topics. So I'm really glad. Thanks for all your help. It's really because you help. I appreciate it. Thanks a lot. Let me just say then about the quiz. I'm going to give your quizzes back. In general, I thought you did real well. But I would like to even come back to them. But if I run Valgrind on this code, it's going to give me a warning, or no, an error. These you don't want. There are no errors in STL. If you see an error, then you made it. Okay, you made it. It's not STL. And that's the reason there's an error here, and I can search back and show it to you, but in the program that I wrote, I actually have this stupid copy constructor that I didn't mean for it to be there. And so I really wish I had deleted it. So as a result, what happens here? This is where that error points to. Valgrind can help you find errors. Have you ever used it for that? My kid uses it all the time to find errors in the C++ code. And he's got a lot of them. So the error isn't there. It's going to point, yeah, no, it does. It points here. Because it doesn't know, it's got a in fact, if you look at the error message, it's a dangling reference. That's what Valgrind calls this. I don't know why. But when you try to put this in here, when you do this, it doesn't know what to do. So I gave anybody, if you put Elysium or if you put Clemson, either one, then I marked that right. However, I'd like to tell you that I'll try to make real sure I don't do that anymore. And those of you who think, well, he probably has a lot of errors in his code, I always run the code. So the quiz looks like this. There's no code in the quiz. In the quiz, I use this package called listing, and I just get the code right from there. So I rarely have errors in my code, and that was a rare, painful, by the way. Very painful, because I had to grade your papers 3 times. Okay, so I usually don't have an error in my code, but that's an error that I wish I hadn't had. So if I get rid of this, then let me just talk about this, because we're going to have a test in about 10 days. Do you know what's happening now? I want you to see that, then I'll give you your quizzes back. What is it? Some of you drew it right on your quiz paper. You drew it. You know, don't you? Do you know? Yes. Who can draw it for me? Someone that can draw. Here you go. Can you catch? I guess we can answer your phone.
The first one is string. Which has buff.
You got it.
And pointer. So
Yep.
pointing to memory.
Yep.
Which has lithium in it.
Yep. Perfect. C puts the null by. That's a blank. Close enough.
And then you make a T
You
string,
sure do.
but you don't
And it has a buff. Draw the buff.
Oh, right, it has a buff too. But you don't have a copy now. So it'll point, and you're passing an S as the copy. So it's just gonna point to what this point is pointing to.
Go ahead and draw it.
This.
There you go. I saw that on about 10 quiz papers, which is really nice.
And then when the string copy is gonna get the buffer, it turns the point, what the pointer is pointing to is this. And says, goes to this becomes, so it chooses that to this.
Perfect.
And then when you print out S.
Perfect. That's exactly what happens. Imagine trying to find that buff. Here you are. You've got an S. You've got a T. You put something in T and you changed S. It's like it's liable to cause you to want to use that other language with 4 letters. Or Python, right? No, the answer is we want to write a copy constructor because anytime you have this, what do you have to write? Okay, great, good job. Patrick. Chris Cousin. Casey. Chris Crawford. Nice job. Aubrey. Aubrey. Austin. Cherie. Good job. Ryan, you hear? Oh, Ryan's at the conference. Najee. Wow, Najee. Nice job. Philip. Stephen. Caleb. Lauren. You're going to have to do better. Adam. Jonathan. Joey. Will Collins. Paul Kilgore. I have the grades on my web page, but they're not updated. I've changed a lot of the grades. So if you look on my web page, you did awfully well. Really, it's so many good students in here. I think there were about eight people that got 100. And that's really unusual. Paul. So the grades are actually higher than that, Paul, because I haven't updated those numbers. There are 7 Wangs, 8 Wangs. One of the Asian students, there are 2 Asian students with these real long names, and they differ by exactly 1 letter. It's horrible. So when you put your name at the top, make sure I can read it, because it's really, especially if you're one. I think there are 8 Wangs. How many Wangs are there? Raise your hand if you're a Wang. Only 3 are raising their hand. 4. Wang. I've got to see at least 7 hands. You're a Wang? You're not. You don't know your name. Okay, where's the Wangs? Raise your hands if you're a Wang. 1, 2, 3, 4. You won't admit it. 5. There's more than 5. Maybe they dropped. Gunyang, Gunyon. You didn't have your hand up. I'm not giving you your pick. No, not you. Who's G-U-A-N-Y-A-N? Yeah. Did you have your hand up when I asked for Wang? Okay. Wang. You Gao. You Gao? Wang. Rui. Runzen Wang. You didn't have your hand up. You're a Wang. He doesn't know it. Praveen. Yon Wang. Your hand was up. Thank you, Yon. Yon? I can say Yon. Xin Bai.
Yeah.
How do you say that?
Zimbai.
Zinbai.
Yeah.
Zinbai. Is that all one word? Or? Kabani Nabil. Rahas Tipnis. Sakti Aishwarya Arun Shalom.
I did that.
Oh, thanks for putting all three names. Wang. Y-U-X-I-A-N-G. Well, you're a Wang. What do you? Oh, you're not even a Wang. Yuxiang Wang. Yuxiang? You had your hand up. Is that you? Y-U-X-I-A-N-G? Kiji. Kiji. Yon Zhang. Yon Zhang. Did I get that right? You're lying. Yaolin Zhang. Chong Sun. Sugitha Sanda Kumari. Bin Hee Yi. No, I can't let you see his grade. Feng Li. Feng Li. Zhao Lin Jing. He's a Wang. Jing? Yeah. Gao. Zhang Jing Gao. Santosh Parasel. Jing Wang. Jing Wang.
Yeah.
Jing. Sayu Pan. Natasha Shan. Shaw. Natasha Shaw. Natasha Shaw. Zephu Wang. Zephu. You raised your hand real high for that one. Wu. Sinru Wu. Is that you? Praveen Kumar Andi. That's not you? That's you? Are you Lobo? Praveen Lobo? Praveen Kumar Andi. That's you? Himanshu Chatter Devar Harmer. Did I get it? Zhao X Yi. Y-E. How many Y-E's are there? Lu. This is Zhao Yuan. Liu. L-I-U. Is your first name begin with a Z? Yaon Jiong, Xiong. Is that you? Make sure you look at the name. Aubrey, we're done. All right, have a great week. I'll see you on Tuesday. No, don't come to my office. Yeah. It's 40 to 60. I always have yeah. So it doesn't vary. Oh, I'll look at it. What's that? Yeah, let's talk. I just want to make sure.
is A.